I really am pleased to be here today addressing the Southwest Florida Climate Summit. Also very privileged to follow Senator Rubio's very cogent remarks and your own opening remarks. So it's a pleasure to be here. I was asked to talk today about the current state of the climate, both nationally and certainly with the focus on Southwest Florida. And we're going to look at the current climate, the changes that have been observed so far, and also a little bit delve into what we can expect in the future. And we are going to do this by looking at a series of climate and weather threats, including rising temperatures and extreme heat, increased extreme rainfall, and the other side of that is drought. We'll take a quick look at sea level rise and also changes in hurricanes and tropical storms. And one more remark on these weather and climate threats. Climate change is not bringing us any new weather or climate threats. These are the same threats we have been dealing with as a society all along. However, there is growing and overwhelming evidence that climate change is changing the nature of these threats, either their frequency and or their severity. So while there are no new threats, climate change is certainly impacting the existing ones. And with that, we'll go ahead and get started, and we'll begin on the next slide by looking at one of the drivers of these changes, or the key driver, and that's the anthropogenic increase in greenhouse gases. And this is a graph I think we're all very familiar with, the famous Keeling curve, where Charles Keeling from Scripps Institute set up a laboratory on the top of Mauna Loa in the Hawaiian Islands to very carefully measure the concentration of carbon dioxide in the atmosphere. And here we see the results of those observations beginning around 1954, where we were at 315 parts per million of CO2 in the atmosphere. And we see over the decades a steady, even exponential rise in the carbon dioxide concentrations to now we're over 420 parts per million with really no slowdown in sight. So that's what we've done to our atmosphere with the burning of fossil fuels. What I don't show is there's also a carbon dioxide record from ice cores in Antarctica, where by looking at the different layers and the air bubbles trapped in these ice cores that are drilled down thousands of feet, they determine CO2 concentrations going back nearly 1 million years. And this encompasses 4 or 5 different ice age and warm interglacial periods. And at no time in this nearly 1 million year record were carbon dioxide concentrations as high as they are today. So this is the grand experiment we've done on the planet, and without knowing really where it's going. On the next slide, I'll show another very familiar slide, and this is a graph of global average temperature since about 1880. And there are 4 or 5 centers around the world that track this global average temperature by putting together all the historic instrumental records, and they all pretty closely agree. But some alarming things with this graph. We do see an increase of temperature since about 1900 of nearly 1 degree Celsius now. And also another alarming thing is each of the last 6 years have been among the 6 warmest on record. 2016, when we were under the influence of a very strong El Nino, is still the record holder. 2020 placed second. We actually got a reprieve in 2021, where we're only the 5th warmest due to the opposite phase in the Pacific Ocean, or La Nina. But also, this warming is not distributed evenly across the planet or even the country. And this map on the bottom shows the warming observed over the United States in the 20th century. And what really sticks out is parts of the Southeast United States actually cooled a little bit in the latter half of the 20th century. And this was known as the global warming hole. Well, in the next few slides, I'll show you that in the 21st century, that hole has closed very abruptly, and we have caught up with the rest of the globe. So on the next slide, we'll take a look at US and Florida temperatures. I want to call your attention to that bottom left graph, and that is the statewide average temperature for Florida since 1895, and it's simply smoothed with the 5-year running average. And what really sticks out is the last several 5-year periods are now a full 2 degrees Fahrenheit warmer than any other previous 5-year period on record. So we've seen a very abrupt warming here in the state of Florida over the last 5 to 8 years. Some really shocking statistics. If we look at Florida monthly average temperature, 78 out of the last 83 months have all been warmer than normal. Only 5 months of cooler than normal temperatures in the last 6+ years. That included a streak of 31 months in a row, or nearly 3 years without cooler than normal temperatures. And interestingly, overnight temperatures are affected more than the daytime high temperatures. And we'll go into that in a little more detail. And the map on the top left just shows that it's similar across the Southeast United States. All of the dark red areas, the last 5-year period has been the warmest 5-year period on record. So on the next slide, we'll take a little closer at what happened in 2021 calendar year. This map simply shows the historical ranking for each state of average temperature in 2021 out of 127 years. And while no state set a record in 2021, several were ranked second warmest, many more, all in the dark orange were in the top 10. And even in the Southeast, where it was a little cooler, all these states still ranked in the top 20. Overall, it was the 4th warmest year as a whole in the United States since 1895. So we'll go on to the next slide, and we'll talk about this rise in nighttime temperatures. And here I show a graph of average nighttime temperatures for the Southwest Florida area, again, since 1895. And what we see that the 20th century average was around 63 degrees Fahrenheit. We're now, in the last 5 to 8 years, we're running closer to 67 degrees Fahrenheit. So a 3 to 4 degree warming in nighttime temperatures. What are some of the impacts? Elevated coastal temperatures in coastal waters. So we know well that Southwest Florida is experiencing outbreaks of red tide and other harmful algal blooms nearly every year. Also, cumulative stress on livestock and on humans, heat-related illness and stroke, especially vulnerable populations, construction workers, agricultural workers. Something I learned just recently, prison populations. 75% of Florida prisons are not air conditioning. So these nighttime temperatures certainly have an effect on the health of prison populations. And just on the graph on the bottom left shows coastal temperatures at Virginia Key and Miami. And what we see is in 2021, there were 3 months in a row where these coastal temperatures averaged over 90 degrees Fahrenheit. Huge implications for marine life, seagrasses, corals. So we'll go on to the next slide. And so far we've talked about changes in the average temperature or average overnight temperature. And you might say, what does a change of a couple degrees, what difference does it really make? Well, it's not just the average that's changing, it's the entire probability or historical distribution of temperatures. And this graph shows how, as this whole distribution shifts towards warmer, the changes in the extremes are very much amplified. Much more occurrence of extreme heat, much fewer occurrences of extreme cold as this whole distribution shifts. We'll go to the next slide and start looking at extreme temperatures. And for non-Floridians, this might come as a shock, but it's actually North Florida and the Panhandle is more prone to extreme hot days. And this map simply shows the typically hottest day of each of the summer on average, and up near 99 or 100 for North Florida and the Panhandle. But down in South Florida, where we're surrounded by the water, we get the easterly trade winds and sea breeze. The hottest temperature each summer is significantly less. So luckily we're a little less prone to extreme heat, but when it's combined with humidity, there's still problems. As we'll see on the next slide, this is just a quick look at heat index, which is a combination of heat and humidity and how it affects the human body. And this graph is from Brian McNulty at University of Miami, and it shows the increase in the number of hours each year of heat index values of 90, 95, or 100 degrees or more. And for all these thresholds, we do see a significant increase since the year 2000. So we'll go to the next slide. And one last thing to talk about is this overnight cooling. This is from the US National Assessment. And again, this is from the Miami International Airport. They consider a warm night where the temperature never drops below 75 degrees Fahrenheit. And we see from this historical record back in the 1940s and 50s, Miami could expect around 50 or less of these warm nights. What we see is a steady increase where now Miami can expect over 150 of these warm nights each year, or nearly half the year. So a very significant increase in warm nights. On the next slide, we'll start talking about other threats and changes in rainfall. And here's a graph for average rainy season rainfall in Southwest Florida. What we see is that a lot of year-to-year variability, but really no increasing trend. However, the past 5 or 7 years, we really have avoided major drought, so that's good news. So we're not really seeing a change in the amount of rainfall, but on the next slide, this is well documented in the US National Climate Assessment. We are seeing an increase in extreme rainfall. And this graph just across the entire Southeast shows the increase in daily rainfall amounts of 3 inches or more, which is certainly an extreme rainfall event. And we see a very steady increase decade by decade as the climate warms. So we'll go on to the next slide and talk a little bit about the other side and drought. And this graph shows the Palmer Drought Severity Index across the state of Florida. And while there's really no trend towards more drought, and like I say, recent years have been kind to us, there is a very strong correlation with the state of the Pacific Ocean, the El Nino La Nina cycle, as we see the periods of drought line up very nicely with the periods of La Nina in the Pacific Ocean. We'll go ahead to the next slide and talk about sea level rise. I'll quickly touch on that because I believe our next speaker will cover it much more thoroughly. But there's 2 mechanisms for sea level rise: the thermal expansion of the ocean water as the oceans warm, and the melting of glaciers and continental ice sheets. And we can track sea level rise with a network of tide gauges. We show the different long-term tide gauges going on. So we have a fairly steady rate of sea level rise similar to the global value. And here in Naples, Florida, we see a steady rise of around 3.2 millimeters per year, or around 9-10 inches per century. So we'll go ahead on the next slide. And the latest report from NOAA says we can expect another 10 to 12 inches in the next 30 years, and up to 2 feet or even 3 to 7 feet by 2100 if we don't curtail our emissions. So does even a little bit of sea level or the lower bounds make a difference? Well, this graph from the tide gauge at Virginia Key in Miami really illustrates how it does. Prior to 2016, that 4-foot level was only eclipsed when under the influence of storm surge from a nearby hurricane. However, from 2016 on, normal astronomical or king tides eclipsed that 4-foot level every year, including 5 or 6 times in 2019. So with that, we'll go ahead and skip to the end, to my summary slide. I'll touch on that in the summary. These are our different climate and weather threats, and what we can say will happen with increasing confidence in the top. Sea level rise, this report from NOAA says at least 2 feet by 2100 is locked in. Could be higher if we don't curtail greenhouse gas emissions. Temperature is very likely to continue to rise with increasing greenhouse gases, probably a little less in Florida than the rest of North America.